What if factories could think for themselves, not just follow instructions, but actually sense, learn, and adapt in real time? That's no longer science fiction. It's the reality unfolding right now on production floors across the world. Today, we're exploring smart factories, how data, machines, and human creativity are coming together to transform manufacturing. I'm Chris Davis, and in the next few minutes, we'll journey through how these intelligent ecosystems work, the technologies driving them, and what this means for the future of work itself. Here's our roadmap for today. We'll start by defining what a smart factory is and how it differs from the broader concept of smart manufacturing. Then we'll look at technologies that make all this possible, from robotics and AI to cloud applications, 3D printing, and digital twins. We'll explore how smart factories operate, the benefits they deliver, and the major challenges they face. These challenges, like cybersecurity, workforce transformation, and overall cost. Finally, we look ahead to what the next era of manufacturing might look like. Imagine a factory that behaves like an intelligent organism. Every machine and sensor gathers information, communicates with others, and adjusts on the fly. Smart factories operate like living ecosystems, collecting data, analyzing it, automating tasks, and constantly optimizing performance. They don't just automate, they learn. This is the essence of Industry 4.0, the fusion of digital intelligence with physical production. It is important to separate smart factories from smart manufacturing. Smart manufacturing is the bigger picture. It's the strategy of connecting technologies across the entire supply chain, from design to delivery. The smart factory is the core engine where that vision comes alive, where sensors, algorithms, and robotics turn digital insight into physical action. So if smart manufacturing is the concept, the smart factory is the proof. Six major technologies powering smart factories are the Internet of Things, artificial intelligence, robotics, cloud applications, 3D printing, and digital twins. These aren't just separate tools. They work together as an integrated ecosystem where information flows freely, learning happens continuously, and performance improves with every cycle. The Internet of Things, the physical objects that have sensors, software, processing ability, and other tech that exchange data over communication networks. The IoT in manufacturing is an increasing trend where companies can take advantage of faster networks, smarter devices, and improvements in edge technology. Robotics is the muscle, then AI is the brain. Artificial intelligence, or AI, refers to systems that can perform complex cognitive tasks, such as recognizing patterns, making decisions, and even predicting outcomes. In smart factories, AI optimizes production schedules, detects defects, manages logistics, and so much more. It learns from every data point, continuously refining its accuracy. AI systems don't just follow rules, they discover new ones. They turn raw data into insight and insight into action. Can AI do? AI can optimize production scheduling by recognizing production issues in real time. AI can detect defects, can be used to identify, isolate, and correct defects in a manufacturing environment. And AI can optimize logistics by integrating artificial intelligence into the supply chains. When we think of robots, we often picture mechanical arms on an assembly line, much like this image. But robotics today is far more sophisticated. A robot can be any artificial system, physical or digital, that performs tasks under unpredictable conditions without human oversight. It can learn from the experience, improve its performance, and even emulate human cognition. Modern robots use machine learning, neural networks, and decision-making algorithms to act rationally, achieving goals through perception, planning, reasoning, and communication. Cobots, collaborative robots, are programmed to interact with human workers and introduce a different scope of manufacturing flexibility and efficiency to the process. The major difference between cobots and robots. Robots are usually isolated from workers using safety barriers, while cobots utilize AI and operational control measures which enable them to be in areas of production directly interacting with humans in a safe manner. All of this data has to live somewhere, and that's where the cloud comes in. Cloud applications are the digital backbone of smart factories, offering these key advantages: accessibility, scalability, ease of maintenance, cost effectiveness, integration, and security. In short, the cloud lets factories operate without borders, securely and efficiently. 3D printing, or additive manufacturing, is transforming production. It builds objects layer by layer, using only the material needed, dramatically reducing waste. It also enables designs that were once impossible. It speeds up prototyping and allows mass customization. These applications are incredible in aerospace, where lightweight, strong components that reduce fuel use while meeting strict safety standards can be made. Rapid prototyping of complex parts, making vehicles lighter and more efficient in the automotive industry. In healthcare, custom prosthetics and medical devices are tailored to individual patients. Personalized jewelry and furniture designed exactly to your taste are ways that 3D printing can be applied to consumer goods. Digital twins might be the most visionary technology of them all. A digital twin is a virtual replica of a real-world system, such as an entire factory floor. It simulates operations, tests scenarios, and predicts performance. Before you change a layout or add a new production line, the twin shows how it will behave without disrupting actual production. It's like having a crystal ball for your business operations. Siemens takes this concept even further with what it calls the comprehensive digital twin. This model integrates every part of a product's life cycle, from design and engineering to manufacturing and maintenance, into one single source of truth. It delivers sustainability through digital prototypes that reduce waste and resources used, speed, streamlined virtual design and testing, accelerate go-to-market time, Optimized operations with real-time data insights guide better decisions. Cost effectiveness. Productive maintenance reduces downtime and waste. Resilience. Factories can test scenarios and prepare for disruptions before they occur. And collaboration. Teams across design, production, and logistics all work from the same digital thread. The comprehensive twin makes factories not just connected, but intelligent, integrated, and future-proof. So how does a smart factory actually work? Think of it as a four-stage feedback loop: data collection, analysis, automation, and optimization. Machines and sensors collect real-time data, everything from motor vibrations to temperature and air quality. This data is then transmitted through the Internet of Things. The data is then analyzed using AI and big data tools. This helps interpret that data in real time. This helps to identify patterns, predict outcomes, and even can provide suggested improvements. During the automation process, robots adjust speed, systems schedule maintenance, or materials can be routed or rerouted automatically. During the optimization process, the system learns from each cycle, continuously refining how it operates. This living, learning loop allows smart factories to adapt instantly and operate at peak performance almost all the time. Smart factories bring together technology and intelligence to make manufacturing faster, safer, and more sustainable. Let's explore the key benefits: increased efficiency, predictive maintenance, improved quality, and reduced waste and downtime. By connecting machines, software, and sensors through data networks, smart factories can coordinate production in real time. This means less idle time, smoother workflows, and faster responses to change. Every process becomes a synchronized part of a much larger system, like instruments in a perfectly tuned orchestra. Predictive maintenance: machines monitor their own health. Sensors detect early warning signs, such as a subtle vibration or heat increase, and schedule repairs automatically before failure. This minimizes downtime, extends equipment lifespan, and saves enormous amounts of money over time. AI-driven inspection systems catch defects as they happen, not after. That ensures consistency and minimizes rework. Quality becomes proactive instead of reactive, built into every stage of production, not just testing at the end. Smart factories also reduced waste by optimizing resource use. They track materials, energy, and time in real time, spotting inefficiencies immediately. Downtime drops dramatically, and sustainability improves as fewer raw materials and less energy are wasted. It's efficiency with an environmental conscience. Together, these benefits help companies cut costs, improve reliability, and stay competitive in a data-driven world. But no transformation is without its challenges. For all their advantages, smart factories face three major hurdles: cybersecurity risks, workforce transformation, and high implementation costs. Let's take a closer look. Connectivity is powerful, but it also opens doors to cyber threats. Each connected sensor or system becomes a potential entry point for hackers. Protecting data requires constant vigilance, strong encryption, and secure network design. Cybersecurity is no longer just an IT issue. It's a core part of manufacturing strategy. The next big challenge is people. Manufacturing faces a serious skills gap, and it's growing. A recent report estimates that by 2030, the U.S. could have over 2.1 million manufacturing jobs unfilled. Why? Because as older workers retire, younger generations aren't entering manufacturing fast enough, especially in technical, digital, and adaptive roles. To thrive in manufacturing 4.0, companies need workers who can think critically, adapt quickly, and operate complex smart systems. This is more than a talent shortage. It's a transformation of what manufacturing work means. The third challenge is cost. Implementing robotics, AI, and the Internet of Things infrastructure requires significant investment. For many small and mid-sized firms, that's a huge barrier to overcome. But over time, smart factories deliver strong return on investment through lower maintenance costs, faster production, and higher efficiency. The key is thinking long term, investing today to stay competitive tomorrow. So, where does all this lead? Factories are evolving toward autonomy, self maintaining, globally connected, and powered by cloud networks and AI. We're moving towards systems that predict demand, adjust production automatically, and even collaborate across continents in real time. The next generation of factories will be more sustainable, resilient, and responsive, blending digital precision with human imagination. To wrap up, smart factories are redefining what's possible in manufacturing. They use automation, big data, and AI to boost efficiency, quality, and sustainability while continuously learning from every cycle. They're not just changing how we make things, they're changing how we think about making things. The future of industry will belong to those who can merge human intelligence with machine intelligence and keep learning faster than the world changes. Thank you for your time. The insights and data today come from credible industry leaders, including Oracle, McKinsey, Siemens, NASA, and training industry.